So when we're combining like terms, right? We're combining like terms. We look for same variable, same exponent, and we can only add or subtract coefficients, right? Same thing with what we did yesterday. We were only, once our radicals were the same, we were only allowed to add and subtract coefficients, correct? What happens though when we multiply terms? So when we're multiplying variables and exponents, are you allowed to multiply x squared times x to the third? Yeah, right? So we're allowed to multiply them, one, because they're both x's, but then our exponents change. We have some exponent rules. So when we're multiplying radicals, so for instance, if I have the square root of a times the square root of b, because they're both under a square root, okay, so remember how we talked about square roots versus like a cube root yesterday? How those aren't the same? So when they're both under the same radical, so a square root or cube root, you can multiply what's inside. So I can do the square root of a times b. Does that make sense? Okay. So if I give you the square root of 5 times the square root of 10, because they're both square roots, I can multiply what's on the inside. 5 times 10 is 50. So I have the square root of 50. Now before I just call it quits and leave it there, what's something that you know about radicals? I think I heard a whisper in the back. Maybe not. You can always try to simplify. So I want you to make a note to yourself before we do that. Always try to simplify your radical. Okay, your final answer has to be simplified. Just like when we're dealing with fractions, we always have to have a reduced fraction. You always need to simplify that radical. Can I break down 50? Yeah, right? 5 times 10. You just multiplied it together. 10 breaks down to 5 times 2. So I have a pair of 5s and a leftover 2. So final answer for this problem is 5 square root of 2. Okay. Could I break down the square root of 10 first and then maybe multiply? Do you think I'll get the same answer? You looked at Mr. Garza and he shook his head yes. Okay, so you can simplify a little bit first and then multiply. You can multiply and then simplify. Whatever works best for you. We're going to do a couple basic ones and then we're going to do one more. No, we'll do 2. Okay, why don't you try the square root of 12 times the square root of 6 and the square root of 10x times the square root of 2x. Twelve times 6 gives me
72.
the square root of 72, but I'm going to try to break it down first. Well, I know 12 times 6 multiplies by 72 because I just did it, right? If I break down 12, I get 2 and 6, and I'm going to stop because I see a pair of 6s with a leftover 2. My pair comes out, my leftovers stay inside. Are we okay with that one? Okay. For number 3, 10 times 2 is 20. What's x times x? X squared. Okay, so if you broke down 20, you got 4 and 5, and then 4 breaks down to 2 times 2. So I have a pair of 2s and a leftover 5. You also have 2 x's. Is that a pair? Again, you'll notice all of my pairs are circled. All my circled stuff comes out. So I have a 2 and an X on the outside. My leftovers are underlined, so I'm left with 5 on the inside. Are we okay with that? Not too bad? Okay, so let's add a layer. What if I give you 2 square root of 5 times 3 square root of 6? Okay, before we actually solve this. 2 square root of 5 times 3 square root of 6. So what's different about this one compared to the other ones? The what? Okay, so there's a coefficient out front, right? So if you have a coefficient out front, you're just going to multiply those numbers like you normally would. 2 times 3 is 6. And with radicals, as long as they're the same radical, so the square root, right, I can multiply what's inside. So 5 times 6 is 30. Is 30 going to break down at all? Right, because 5, it will break down to 5 times 6. It's right here. And then 6 breaks down to 2 and 3. Are there any pairs between those? So I can just leave my answer like that. Okay, so if there's coefficients on the outside, you're going to multiply them together, and you multiply what's on the inside of the radical. Are you okay with that? Yeah? Okay, so why don't we look at this one? We can do it together because there's kind of a lot going on here. So I have 3 square root of 4x times 2x square root of 2x. Where should we start? The outside. Multiply the outsides. 3 times 2x is 6x. Now I'm going to multiply the insides. 4x times 2x? 8x squared. Good. 4 times 2 is 8. X times x is x squared. I'm pretty sure I can break down what's on the inside. Right? So I know 8 breaks down to 4 times 2 and then 2 times 2. So I have a pair of 2's and a leftover 2. I also have 2 x's. That would make a pair. Everyone agree with that? So I have a 2 and an x that it's going on the outside, but what's already there? A 6x. So this 6x is already here, and now I'm taking out a 2x, and I'm leaving a 2 inside. 6x times 2x, 12x squared. We okay? Okay, so I'm gonna have you try one. We're kind of just adding a lot of layers to this today. So why don't you try b square root of 8a times b square root of 3a. Those are b's, not 6's. Really good answers. So first thing you did was b times b, which is b squared. And then 8a times 3a is 24a squared. Right? Don't forget to simplify if you can. So 24 breaks down. I saw most of you do 8 and 3, so I'll do the same. That breaks down to 4 and 2. And then 2 and 2, so I have a pair of 2's, a leftover 2, and a leftover 3. Don't forget your variables inside. I have 2 a's. Is that a pair? Okay. So already on the outside is a b squared. What else am I taking out? A 2 and an A, and what's left over inside? 6. 2 times 3. Okay, so here's what I already had. Here's that radical simplified. Now I'm going to combine everything. Now, we write our coefficient out front, and then we typically write our variables in alphabetical order. So it should be 2ab squared and then square root of 6. Is it wrong if you do b squared and then a? No, but typically we'll write our variables in alphabetical order. Are you all okay with that? Okay, you ready for another layer? Oh no, here we go. Okay. So here we have the square root of 3 and then times the square root of 2 plus the square root of 3. Okay. So I'm going to ignore this real quick and just look at what's inside the parentheses, because according to order of operations, you do what's in parentheses first, right? According to our lesson yesterday with adding and subtracting radicals, can I add those together? No. Why? They're not exactly the same. Everyone okay with that? Okay, so there's nothing I can do in the parentheses, so now I have to look at the whole thing. What does that look like to you? Distributive property, right? So let's distribute. When I distribute, and I'm going to write these steps out. Some of you are going to be able to do it in your head, but I want you to see what's happening. So I'm doing the square root of 3 times the square root of 2. Right? And again, some of you are going to do this in your head, plus the square root of 3 times the square root of 3. That's what distribution is. You multiply what's on the outside by everything on the inside. Right? Okay, so one thing at a time. What's the square root of 2 times the square root of 3? The square root of 6. Plus, what's the square root of 3 times the square root of 3? Square root of 9. Now, don't we always have to try to simplify? Can I simplify 6? Is that going to break down to anything that gives me pairs? No, because it's 2 and 3. What about 9? It's 3 and 3, right? So really I have a pair of 3s. Do I have anything left over? No, so the square root of 6 plus 3, right? The square root of 6 stays. The square root of 9 becomes 3. Can I add the square root of 6 and 3 together? No, because this one has a radical and this one doesn't. The only thing we typically do is we write the constant first and then the radical. Will I take both answers? Yes. But we typically write the constant first and then the radical. Something you should notice that will make your life a little easier is anytime you multiply two radicals together that are exactly the same, what happened? The radical went away and all I had left was what's inside. Do you see that? So if I ask you what the square root of 2 times the square root of 2 is, what are you going to tell me? 2. What about the square root of x times the square root of x? X. Right? Because x times x is x squared. And if we break it down and look for a pair, how many pairs do we have? 1 pair of x's. Do you see that? Okay. Let's try another one. Actually, you try this one before we add a piece. If I distribute here, I'm not going to write it out, I'm just going to do it. The square root of 5 times the square root of 6 is the square root of 30. And then I have the square root of 5 times negative square root of 5, so I know it's going to be a negative. What's the square root of 5 times the square root of 5? 5. Right? It would be the square root of 25, and that breaks down to 5 times 5, which is just 5. If they're exactly the same, the square root goes away, and you just have what's on the inside. Now, I said we write our constants first and then our radicals. If you kept it like that, that's okay. If you switch it, you need to make sure that negative stays with the 5. So it should be negative 5 plus the square root of 30. I will take either answer. If it's confusing for you to switch it, that's fine. But as you move forward into IM3, this is how they're going to probably have you write it. Can I break down 30? I know it's 6 and 5. 5 doesn't break down. 6 is 2 times 3. I have no pairs. Okay? All right. What happens if we have something like this one? We're going to do it together. Okay. If I distribute, what do I actually multiply together? The radicals. So what do you think happens with this 2 on the outside of the first one? It just stays on the outside. Because what's really on the outside of this square root of 5? Well, 1. So 1 times 2 is 2. 5 times 6 is 30. So that stays underneath the square root. Plus 1 times 3 is 3. 5 times 3 is 15. Okay, are these radicals the same? Can I add them together? No. Can I break them down? So it's 5, for 30 it's 5 and 6, and then 6 is 2 and 3. Are there any pairs? No. For 15 it's 5 and 3. Are there any pairs? If there's nothing else you can do, you're done. Always check if you can simplify. Sometimes you won't be able to. On a scale of 1 to 5, where are you right now? 4s, 5s? Okay. I see maybe a 3 in there. Okay. Hopefully this does not throw you over the edge. Here we go. Wow. I see some what faces. What does this look like to you? The one thing we did like a month ago when we multiplied? The box or distribution? Yeah? So you can do it either way. Let's organize it with the box. If you think you can do it the other way, you don't have to. But I think I'm going to organize this one with the box. Okay, we can use the box. It's 2 terms by 2 terms, so my box is a 2 by 2. I have the square root of 3 and a positive 2, and the square root of 3 and a 5. If you want to distribute, you can. Okay, one box at a time. What's the square root of 3 times the square root of 3? What's the square root of 3 times the square root of 3? What's the square root of 3 times the square root of 3? Okay, let's go back up here. What's the square root of 2 times the square root of 2? 2. What's the square root of x times the square root of x? X. What's the square root of 1,000 times the square root of 1,000? 1,000. What's the square root of 3 times the square root of 3? Some of you did not say 3. If they're exactly the same and you multiply them together, you just take what's on the inside. Because 3 times 3 is 9, and what's the square root of 9? 3. Okay? Square root of 3 times 5, what's that? 5 square root of 3. Good. You can't actually multiply it together, so we're just going to write it together. What's 2 times the square root of 3? 2 square root of 3. And 2 times 5 is 10. Now, do you remember when we did the box method and we were multiplying variables? What did we say about these diagonals? They should be your like terms. Are they like terms? Yeah, because the square root of 3 and the square root of 3 are exactly the same. Do you notice anything else about this problem? Well, let's start with that. 2 plus 5 is 7 square root of 3. I also have a 3 and a 10. Are those like terms? 3 plus 10 is 13. Where should I write that? In the front. So unlike when we multiplied before, things are going to kind of simplify and cancel for us, and we're probably going to have a nice, easy problem at the end. I know I can't simplify the square root of 3, which means that's my final answer. You okay with that? Can I give you one? Someone said no. I'm sorry. I want you to try. We're going to do 2 more. You're going to do this one, and then we're going to do one more together. I know. Before I actually solve this, did anyone notice anything about this problem? I know someone did. Yeah? What did you notice? There's a negative. Okay. What else did you notice? They're going to what? They're going to cancel out each other? Tristan's looking back to see what it's called. Difference of squares. Difference of squares says if they're exactly the same with one positive, one negative, what can I do? What's the trick? If they're exactly the same with one positive, one negative, what's the trick say I can do? Multiply the first terms and multiply the last terms. What if I didn't see that and I don't know what the trick is? What am I going to do? You're going to do the box, or you're going to distribute like you normally would. Okay? So I'm going to do the box because I want to show you something. If you saw the trick, that's great. So square root of 7 and 2, square root of 7 and negative 2. What's the square root of 7 times the square root of 7? 7. Square root of 7 times negative 2? Negative 2 square root of 7. 2 times the square root of 7? 2 square root of 7. And what's 2 times negative 2? Negative 4. Okay? If these are my like terms, I can add the numbers out, the coefficients out front, right? Because they're exactly the same. What's 2 minus 2? 0, which means they cancel out. And what's 7 minus 4? If you use the trick, you would have the square root of 7 times the square root of 7, which is 7, and 2 times negative 2, negative 4, and 7 minus 4 is still 3. Okay? You don't have to write this, but I want you to tell me what this means. What does that mean? Okay, Because some of you still think you can do weird things with this one. Square root of 3 plus 5 squared means I have 2 sets of those, and I would use the box or I would distribute. Okay? Now where are you at from 1 to 5? Still a 5? 4s and 5s? Okay. We have, how much time? We have 4 minutes.